Alright, so far we've been talking about rigid transformations, and what a rigid transformation is if you take the parent function, let's call x squared out here, and we simply move it around. We're not changing the actual shape of it. So we can move it down a little bit, but it's the same general shape. We're not taking a parabola and shrinking it or stretching it. Alright, so a shift from one to the next would be called a rigid transformation. And if we're changing the size, the stretch of a function, this would be a non-rigid transformation. So let's look at some examples here. Compare the graph of each function with the graph of f of x equals x. The way I remember this is fractions equal fatter. Now what I mean by this is fractions smaller than 1, like 1/3 here. Obviously we could make 3 over 1 and make it a fraction. But what I'm really talking about is if I see a fraction that's smaller than 1, our graph is going to get fatter. It's going to get wider. Conversely, if it's a fraction bigger than 1, or just a whole number, like 3, it's going to get skinnier. So if our original absolute value function looks like this. This is f of x equals absolute value of x. Then this function is going to be much steeper. Whereas this function will have a slope of 1, this function will have a slope of 3. Conversely, if we look at the 1/3, if this is our original absolute value graph, then 1/3 is going to be much fatter or shallower, since it'll have a slope of up 1 for every over 3. So let's see if you can take that and answer problem 29, which involves a non-rigid and a rigid transformation. So go ahead and try this, pause me, and press play when you're ready for an answer. Alright, the parent function on this is f of x equals x squared, so we're dealing with a parabola. On this, step by step, we're going to go up 4, and then we're going to let's call it stretch. Stretch 2 over 3 wider than x squared. So this factor right here is our stretch factor. So if we're going to go ahead and graph this thing, we're going to go up 4, 1, 2, 3, 4. Normally with a parabola I would go over 1 and up 1 for my first dot. On this one, I'm going to go over up 2/3 and over 1 for my first dot. It's going to be a much, if this is the original, then my graph is going to be not a ton, but just a little bit wider than the parent function. And so D, let's use our parent function to get a new answer, g of x in terms of f of x. G of x equals 2/3. Here's our parent function, f of x plus 4. We're just simply substituting f of x for x squared in the original problem.